Hello students, Newton's laws of motion. These laws are very popular. There will be three laws. First law, second law, third law. Newton's laws of motion. First law. An object will be in the state of rest or uniform motion until an external force applied over it. Once again, an object will be in the state of rest or uniform motion until an external force applied over it. If we are not applying any force over a body, its state of rest will be same and of motion also will be same. Not applied any force, no change of rest or motion. Once again, first law. An object will be in the state of rest or uniform motion until an external force applied over it. This first law is also called law of inertia. Newton's first law also called law of inertia. Inertia is a property of a body which opposes the change of state of rest, motion or direction. Inertia is a property of a body which opposes the change of state of rest, motion or direction. Listen carefully. It's a property of first law. Inertia means it will have the property of first law. It does not allow to change its state. There are again rest, motion, direction. So if it is in rest, it does not accept to be in the motion. It is called inertia of rest. Opposes change in the rest. Inertia of motion opposes change in motion. Inertia of direction opposes change in direction. So all these three are called inertia of rest, inertia of motion, inertia of direction, opposing its state. Before going to Newton's second law, let us know about momentum, indicated by capital P. P equal to small m, small v. Product of mass and velocity. P equal to mv. Momentum. P equal to mv. Now we will see second law depended on momentum. Rate of change of momentum is called force. Momentum is nothing but mass into velocity. Newton's second law is rate of change of momentum is called force. Rate means by time. As we know, force equal to rate of change of momentum, that is delta P by delta T. delta P is change in momentum, delta T is change in time. Now we will derive F equal to ma from second law, Newton's second law. P1 is initial momentum, for example, that is small m, V1, velocity, initial velocity is V1. P2 is final momentum, mv2. Change in momentum, delta P equal to P2 minus P1. Change in time, delta T equal to T2 minus T1. Look at the page carefully. Force equal to P2 minus P1 by T2 minus T1. Look at the application, mv2 minus mv1 by T2 minus T1. M is common factor. V2 minus V1 by T, that is acceleration. That means V2 minus V1, rate of change of velocity. Yeah, that is ma. Newton's third law. Just action equal to reaction. Third law means action equal to reaction. For every action, there is equal and opposite reaction. For example, throw a ball to the wall. It comes back with the same momentum. Recoiling of gun. When you shoot with gun, it jerk back. That jerk back is called recoiling. Recoiling of gun. Again, one more you can observe when a rocket is in the motion. Ejection of smoke during rocket launching, moving towards the sky. Now answer. Rate of change of momentum is called force. Which law is applied for this? Beautiful, Nana. Newton's second law. Ejection of fuel during rocket launching is the example of wonderful, Nana. Newton's third law. What is Newton's third law? Good. For every action, there is equal and opposite reaction. An object will be in the state of rest or uniform motion until an external force applied over it is the law of wonderful, Nana. Newton's first law. First law is also called inertia. Law of inertia. Inertia of rest is good, opposes change in rest. Momentum P equal to beauty, mass into velocity, mv.